So by allowing the charge q to enter into the magnetic field with having different strengths, we get this observation that the magnetic force acting on the charged particle is directly proportional to the strength of the magnetic field as well. So all these three observations give us the combined result as F is equal to Q times V cross B. Now this cross product also has the angle, the aspect of angle hidden inside it. It is the sine of that angle which affects the magnitude of the force. Why we have taken the cross product of these two vectors? Because when theta is equal to 0, the force is equal to 0, and if theta is equal to 90 degree, then the force is maximum. So, and theta is the angle between V and B. So this cross product gives us the maximum result for theta equal to 90 and the minimum result for theta equal to 0. That is why we have taken the cross product of these two vectors. So this equation shows that the magnetic force acting on a charged particle Q moving with the velocity v in a magnetic field B is equal to Q times V cross B. So according to this equation, when V and B are parallel to each other, that is, if this is the direction of V and this is the direction of the motion of the charged particle and both are parallel, then the angle between these two is 0, and the force acting on this charged particle will also be equal to 0. Similarly, if V is anti-parallel to B, if this is our let me indicate it, if this is the direction of B and then this is the direction of the velocity, similarly here this is also the direction of the velocity, then in this case, in which V and B are parallel and are making an angle of 0 degree, the force acting on the charged particle will also be 0. But in this case also, that is when V and B are anti-parallel to each other, then theta is 180 degree and sine of 180 degree is also equal to 0. So the force will be 0 as well in this case as well. That is, in both cases, when V is either parallel to B or anti-parallel to B, the force acting on the charged particle will be equal to 0. But in case when this velocity vector is perpendicular, if it is perpendicular to B, like this, that is, this is the direction of B and this is the direction of V. Now in this case, V and B are perpendicular to each other, so the angle is 90 degree, and here the force, magnetic force acting on such a charged particle will be equal to the maximum and will have its maximum value. This magnetic force will have its maximum value acting on charge Q moving with the velocity V in a magnetic field of strength B at right angles to the magnetic field. In such cases, force, magnetic force will be maximum and its value will be equal to QVB. Now if we have to define the unit of this B, then we will have to make each quantity equal to a unit value. So this force is equal to 1 Newton, the charge will be equal to 1 coulomb, and the velocity is 1 meter per second. V, we have to determine its unit, and sine of theta will also be equal to 1, which is the case when theta is equal to 90. V and B are perpendicular to each other. So in such case, B will be equal to 1 Newton per coulomb per meter per second, and this thing can be written as coulomb per second into meter. So the unit of B can be written as 1 Newton per ampere meter, and this unit is called 1 Tesla. And remember that this Tesla is a very large unit of the magnetic field, and it is equal to 10 raised to power 4 Gauss. So whenever we are dealing with stronger magnetic fields, we use Tesla, and when we are dealing with weaker magnetic fields, we use Gauss. And 1 Tesla is equal to 10 raised to power 4 Gauss, and 1 Gauss will then be equal to 10 raised to power minus 4 Tesla. Now let us consider the left hand rule, which will give us the direction of the magnetic force acting on a charged particle which is moving in the magnetic field B. Now here you can see the magnetic field lines. This is the north pole, this is the south pole, and the magnetic field lines are in between the north and south pole and are directed in from the north pole towards the south pole. So this is the direction of our magnetic field as indicated over here. The magnetic field is directed from north to south, and this is the direction of the motion of charges. That is, here we have a conducting wire placed perpendicular to the direction of the magnetic field. So this will be the direction of V of the charges. If we indicate it by V over here, this is our V, and that is the velocity of the charges, and this is the direction of B. This is our B. So here you can see that V and B are perpendicular. V and B are perpendicular to each other, and they are forming a horizontal plane. So in using the left hand rule, you will stretch the first finger of your left hand in the direction of the magnetic field B, and the second or the middle finger in the direction of motion of charges, that is in the direction of velocity V of the charges. Then the stretched thumb will indicate the direction of the force, which is in the upward direction. Let me repeat it once more. First finger is stretched in the direction of the magnetic field B. The middle finger is stretched in the direction of the velocity V of the charges. Then this stretched thumb will point in the direction of the magnetic force acting on this charged particle. Now here you can see that this force is perpendicular to the plane formed by V and B. Here the plane is a horizontal plane, The plane formed by V and B is